Quantum physics was first developed just over a century ago, when physicists discovered some of the weirdest, most baffling eccentricities of the subatomic world. Those early experiments led to a beautiful, if counterintuitive, mathematical description of particle physics that has allowed us to make incredible leaps in technology and in our understanding of the universe. In our Quantum 101 series, we've given you just a glimpse of that mind-blowing world where waves can be particles and vice versa, energy is quantized, particles can be in two places at once, and uncertainty reigns. But the story of the quantum universe isn't finished yet. Here at the Perimeter Institute for Theoretical Physics, and at research institutions around the world, physicists are exploring new ideas and searching for answers to all the new questions that quantum physics brings. From the very beginning, quantum physics has challenged our view of how physics works. Right away, physicists noticed that it doesn't play well with Einstein's theory of gravity, general relativity. In the intervening century, both theories have passed every experimental test, but they give us completely incompatible pictures of extreme environments like black holes and the Big Bang. Will we ever find a unified theory that makes sense of them both? And then there's the question of quantum interpretations. If quantum physics really does rule the universe, what do we do about all the seeming paradoxes it brings up? How does quantum entanglement really work? Why do macroscopic objects break quantum superposition? Are new universes really branching off every time we flip a quantum coin?
What excites me most about the future of quantum is experiments which will be conducted in the next decade or two, which will resolve tensions which currently exist between conventional quantum theory and conventional general relativity. Something is going to give in that tension, and these new experiments will provide us the answers.
What I'm most excited about the quantum future is to try to use new technologies like quantum computers to understand what do we mean by what is quantum itself, and also perhaps where the theory breaks down, because then we can build even better theories that will help us get better insights about how the universe works.
I'm excited to make quantum really different, not just for science. We know now that it is going to impact society, and we can start now to bring in people from all kinds of backgrounds to discuss what we want that impact to be on society.
What's exciting for me is that 25 years ago, quantum computing was just pen and paper. Today, we have laboratories around the world who have some prototypes of these quantum computers. What I see in the coming years is that we'll have them so that they can solve problems which are important for society.
The thing that excites me the most about the future of quantum is being able to understand the properties of the early universe by simulating them in the laboratory or on a quantum computer.
The thing that excites me about the quantum future is actually the quantum past, what we might learn about the first few seconds of our universe and its quantum origins that lead to everything we see today.
The future of quantum mechanics. We have not figured out the quantum aspect of space, the quantum aspect of time. So I think that's where the challenge is, that's where the excitement is, quantum gravity.
What I find most exciting is we're at the stage in human history where we're actually building devices, technologies at the quantum level, atom by atom, electron by electron, from the ground level up. And what that opens the door to is building transformative new technologies that can do things far beyond anything we have. We can't imagine what they'll do, and we're literally at the dawn of a new age, the quantum age.
The answers to these questions might be just around the corner. Or it might take another century of exploration, confusion, and discovery before we find the right path out of the theory woods. But if this century is anything like the last one, that wandering exploration will lead us to amazing things every step of the way. Exploring quantum physics brought us CCD cameras, powerful microscopes, microelectronics, quantum computers, and countless other technologies and insights that have changed or are changing every aspect of our world. What will the quantum future bring? I don't know. Let's find out.